All right, this section still continues with polynomials, but what we're going to look at now is actually just solving polynomial equations. And as you can see here in the instructions, we're going to be looking for not just only real solutions, but also imaginary solutions. So some of what we had learned earlier with imaginary numbers will come into effect here. All right, so on this first example, since you're asked to solve these by factoring, you will need to have your equation set equal to 0. So we would have x to the fourth minus 12x squared minus 64 is equal to 0. Now, remember, when you're factoring, you always need to check for a greatest common factor first, but the three terms I have here do not all have something in common, so I don't have a GCF in this case. You got three terms, and if you remember back in chapter 4 when we were doing the factoring, when you had a trinomial, you had three terms. We end up factoring it into the two sets of parentheses. And even though this is a fourth power, whereas in chapter 4 you did a second power, it's actually going to follow the same process. Okay, so since you have x to the fourth, that's going to have to be x squared times x squared. Okay, this is always going to be even, and you're going to want to split it up equally, so don't do like a third power and a first power. Do a second and a second. Split it up evenly. Okay, now let's talk about the factors of 64. Of course, there's several options when it comes to 64. You've got 1 times 64, 2 times 32. Let's see, 4 will go into it 16 times, 4 times 16. Of course, let's see, 8 times 8. Okay, so that's your choices. And the actual choice that you're going to need to use is going to be the 4 times the 16, because we are trying to get a negative 12 in the middle here. So go ahead and put in your 4 and your 16. Okay, going back to the same rules that we had learned in chapter 4, if this last term is negative, we know down here that we have to use different signs, and in order to have a negative 12, that means a negative 16 and a positive 4. Now, you could go another step of factoring because the x squared minus 16 is a difference of squares, but you can't factor the x squared plus 4 any further. You're going to have to use a different process on this, which is a process we learned in chapter 4, which would be taking the square root of both sides. But if I'm going to have to use that square root property on this one, I'm going to go ahead and use the square root property on this one. But you could factor this binomial another step and get the same two answers that I'm going to get by doing square root property. So I'm going to take my x squared minus 16 equals 0, and x squared plus 4 equals 0. So if I add my 16, and then I take square root of both sides, of course square root of 16 is 4, but remember when you're taking square root of both sides, you're always going to put the plus minus. Okay, so you've got two answers here. Okay, so now with the x squared plus 4, you would have to subtract the 4. And now take square root of both sides. I'm going to go ahead and put the plus minus. And we're going to do square root of negative 4. Now, you may remember how to do this and can do this in your head, but I'm going to write down a step for this one. Because of the negative, if you remember what we did before, we separated, the negative with a negative 1. And sometimes we broke down this number, sometimes we didn't, and I'm not going to in this case because 4 is already a perfect square. So the square root of 4 gives me 2, and if you remember, square root of negative 1 will give me I. Now, the exponent, largest exponent that you had for this problem is the fourth power. If you notice, I've got 4 answers, positive 4, negative 4, positive 2i, and negative 2i. So whatever your largest exponent is, that will actually tell you how many answers you're going to have. Okay, next one. The first step that I do here needs to be the same as a while ago. I've got to have my equation set equal to 0. Now you can get 0 on either side. I would suggest that you get 0 on the right hand side because you're going to want to arrange this in descending order, and you're going to want this term that's your leading term with the largest exponent, you're going to want that to be positive. Okay, so I would have 5x cubed minus 5x squared minus 12x equal to 0. All right, next, check to see if you have a GCF. Now, what you have common to all three terms here is an x. So let's factor out the x. Okay, so now this leaves me with a trinomial. So I'm actually going to use the exact same process that I used just on that previous problem. Even though this one's down to a second power, it's a quadratic, it's still the same thought process. So I have 5x squared, so that would be 5x times x. Now with 12, we have 1 times 12, 2 times 6, 3 times 4. Now, the choice that you need here is not as obvious as it was a while ago, and that's because we've got this 5 here that's affecting things now. So you're just going to have to, you know, kind of what I told you before, sometimes you're just going to have to put the numbers in and try it and see if it works. If it doesn't work, then, you know, try something else. What you're going to need here, let's see. You're going to need... Let's see, I don't think this is going to factor for me, because that will give me 20, that will give me 3. Okay, that's not going to work. 15 and 4. Let's see, the 6 and the 2. And the 12. No, actually, this doesn't factor. Okay. Not that you've done anything wrong or I've done anything wrong. It's just not going to factor for us. So we're going to have to go back and think of something different. Okay, so taking out the x was still the correct first step. Now, if you have a quadratic and it will not factor, if you remember, you have what's called your quadratic formula. That's actually what we're going to have to use on this trinomial. Now, let's go ahead. The x that we brought out front, that's actually where you're going to get one of your answers. So if you have a GCF, you bring it out front, then take it and set it equal to 0. So that just gives you x equals 0. That is one of my answers, so you definitely need to write that down. Now, go into the quadratic formula. Okay, so I have my a value is the 5. My b value is -5. And my c value is -12. Okay, so I'm going to rewrite the quadratic formula, so you need to have this in your notes. Okay, so now let's take and substitute in our values. So we would have -5 plus or minus the square root of -5 squared minus 4 times 5 times -12, and this is all divided by 2 times 5. Okay, so of course this would change to a +5. Now, underneath your radical there, of course you can use a calculator to help you out with doing the calculations, but we're going to end up with 265. Okay, and I don't think you can simplify the square root of 265. I'm just checking real quick to see if there's any perfect squares that will go into 265, and I don't believe that there are. No. Okay, so this would actually be the other two answers. Okay, so my largest exponent, remember, was a 3. So right here's one of my answers, the x equals 0, and this is your other two answers because you've got the plus minus. Now, you cannot cancel the 5 and the 10, okay? We had talked about canceling when we did quadratic formula back earlier, and you would have to have simplified this and have a number out front, and then if you could reduce those three numbers, then you would reduce those three. Okay, next one. All right, still dealing with factoring. Now this one's already set equal to 0 for us, but the process that you're going to use on this one is a process you would have learned in Algebra 1 that's called grouping. And kind of what makes it obvious that that's the process you need to use is the fact that you've got 4 terms. All right, so when you're grouping, typically it'll be first two, last two. So when I say group them, we're going to put them in parentheses. Group them together. Now, the sign that you're going to put here in the middle is always going to be a plus sign, and that's not because this is a plus sign. Okay, this being a plus sign just tells you this is a positive 5 when you put it in the parentheses. If this had been a minus 5x, I would still put a plus sign here, but then I would put a negative 5 in here with, or a negative in here with the 5. Okay, so now look, these two have an x squared in common. So you're going to bring out the x squared, and that's going to leave you with x plus 2. Okay, now with here you have a 5 that's in common, so you're going to bring out the 5, which will leave you with x plus 2. Now the thing about grouping is these two parentheses have to be the same. If they're not, then you've done something wrong, okay? All right, now you're going to look at this. This is all one term, this is all one term. And these two terms have the x plus 2 in common. So it's just like GCF again. Since you have x plus 2 in common, then you're going to pull x plus 2 out front. So when you take away the x plus 2 from here, that leaves you with the x squared. You take away the x plus 2 from here, that leaves you with the 5. Okay, so now you are finished with the grouping process. So now we're going to set our factors equal to 0. And we're going to solve each one of these. So this would give me x equal negative 2. Now on this one, we're going to have to use our square root property again. So we would have x squared is equal to negative 5. So x would be equal to plus or minus the square root of negative 5. We've got to take the square root of both sides. Now remember, having a negative underneath, we've got to take care of that. So the square root of the negative 1 is going to give me an I that's out front. And you can't take the square root of 5 and get a nice little whole number out of it. Therefore, the 5 is just left underneath your radical. All right, so if you look back at your problem, your largest exponent was a 3. And so you've ended with 3 answers. You've got the negative 2, and then, of course, the plus minus gives you 2 answers that are down here. 3 answers.